Welcome back to episode 12. For this episode, we will return to a more educational format, teaching people about RAG or Retrieval Augmented Generation and vector databases. First, let's define what is lacking in current AI models.
Well, the thing is, traditional AI models often operate in isolation, like they're pulling answers from thin air or a pre-learned script. They can miss current, nuanced, or detailed information because they don't look outside of what they've been trained on. Now, consider if you only used books you read in high school to answer all of today's problems. You might have some basic knowledge, but you'd miss out on a lot of detail and recent developments. That's what's happening with these older AI models. They're working with a limited, outdated toolbox. Traditional models also struggle with understanding context. They can give answers that are technically correct, but kind of miss the mark because they're not connecting the dots with the wealth of information that's out there. For instance, ask a basic AI model about the latest trends in sustainable fashion, and it might give you a generic response. It's not going to know about the newest eco-friendly materials unless it's been retrained with that data. Now, in terms of the techie stuff, traditional models rely on what we call static embeddings, a way of representing text that doesn't change. This limits their understanding because language and information are constantly evolving. So to recap, current AI has a problem with staying current and fully grasping complex real-world context. They're like outdated encyclopedias, still smart but falling behind the times.
Fascinating. This sets the stage for our next topic, Retrieval Augmented Generation. Could you explain for our listeners what RAG exactly is and how it resolves some of these problems you've identified with traditional AI models?
Absolutely. So, Retrieval Augmented Generation, or RAG, is kind of like giving AI a real-time search engine. Instead of only relying on what it's been trained on, it can pull in information from external databases to enrich its answers. Imagine you have a friend who's really smart, but also super fast at looking things up. You ask a question, and boom, they have a detailed, up-to-date answer. That's RAG in a nutshell. It resolves the problems of static knowledge by allowing the model to fetch the latest info. So when you ask about the newest sustainable materials, it can search recent articles or databases to tell you about, say, mushroom leather or recycled plastic fabrics. Looking under the hood, RAG combines language understanding with information retrieval. It first understands your question, then retrieves relevant documents, and finally generates a response based on this fresh, external data. For example, let's say you ask a RAG-enhanced AI about the impact of a recent event, like a new tech law. A traditional model might not know about it, but RAG actively searches for and then reads about this new law, and then it includes that information in its response. In a bit more depth, RAG uses what's called vector databases, which efficiently store and retrieve information in a way that mirrors how concepts are related in the real world. This facilitates a quick and smart search. In short, RAG equips AI models with the ability to provide answers that are both current and deeply informed by rapidly pulling in data from external sources as needed. It's a game changer for making AI more knowledgeable and context-aware.
Incredible. This concept of AI models being as up-to-date as the latest tweet or news article holds so much potential. Let's talk a bit more about the combination in RAG, the retrieval mechanism, and the generative models. How do they work in tandem to produce these enhanced results?
Sure, think of it as a tag team between a librarian and a storyteller. The retrieval mechanism is like the librarian that scours the library to find the right books on the topics you're asking about. It quickly searches through vast amounts of information to find the most relevant pieces. Now, the generative model is the storyteller. It takes those books the librarian found and weaves the information into a coherent, informative tale. It's designed to understand the context and craft responses that make sense based on what it's just read. Together, they turn your question into an answer that's not only accurate, but also rich with the latest insights. If you ask about the impact of climate change on polar bears, the The retrieval part fetches the latest research papers on that topic, while the generative model synthesizes that data into a digestible answer for you. Technically, the retrieval model uses vector representations to map out the information in a way that reflects its meaning, which allows for lightning-fast and precise searches even in a sea of data. The generative model, on the other hand, uses a technique called language modeling to predict and assemble words into coherent sentences. So to summarize, in RAG, retrieval and generation work together seamlessly to find the most relevant and current information before turning it into an answer that sounds natural. It's a powerful duo that considerably boosts the helpfulness and accuracy of AI responses.
How astute. So we're drawing a vivid picture of a system that modernizes and deepens the AI's grasp of our questions. Moving forward, let us pivot slightly. I'm keen to understand more about vector databases, often mentioned alongside RAG. What exactly are vector databases, and why are they vital in the realm of AI and machine learning? Please give us a beginner-friendly overview.
Imagine you've got a huge box of photographs, but no album or labels, just a jumble of images. A vector database is the tool that helps you not only sort them, but also find any picture almost instantly, based on the content of the photos, like finding all the beach photos or every picture that has a dog in it. In the realm of AI and machine learning, these databases are essential because they organize and search through information based on meaning, not just keywords. So, it's like being able to find all pictures with a happy mood, not just the ones where someone wrote happy on the back. For AI, this means when it needs to find information to answer a question, it can search much more effectively. If you ask, how do economic policies impact small businesses? The vector database efficiently retrieves documents that discuss this complex topic, not just those that contain those exact words. These databases use vectors, numeric representations that capture the essence of the data. These vectors are kind of like unique fingerprints for pieces of information, making it possible to match questions with relevant answers or content that feels similar or relevant. In non-technical lingo, vectors let computers grasp subtleties in our language and concepts, so they can provide more accurate, nuanced information. So, wrapping up, vector databases are super important because they let AI sort, understand, and find the right bits of information quickly and smartly, much like having a well-organized, lightning-fast virtual assistant at your beck and call.
The metaphor of photos and fingerprints makes the concept tangible for our listeners. Excellent job there. Let's explore the synergy between RAG and vector databases. How does RAG utilize these databases to enhance its efficiency, and what does that mean for the user's experience?
Thanks. Now, let's dig into how RAG and vector databases are like cookies and milk, better together. RAG uses vector databases to nitpick the exact information needed from the whole internet's haystack in milliseconds. So when AI taps into this database, it's not just blindly guessing, it's precisely lining up your question to the knowledge out there. For the user, this is like having a conversation with someone who has instant access to the world's libraries and can still talk to you in plain English. Your experience becomes incredibly smooth. You ask complex questions and get informed, up-to-date answers as if you were talking to a panel of experts. Technically, RAG leverages the speed and relevance powered by vector databases to sift through potential responses, picking only the best matches before crafting its reply. It can understand the semantic meaning of your query and fetch related content, even if there's not a single keyword match. For a more realistic example, say you're asking about the influence of a newly discovered dinosaur species. RAG would dive into its vector database, find current papers or articles on this discovery, and pull out the essential points to give you a succinct rundown. To wrap up, the RAG's use of vector databases means users get to interact with a smarter, more informed AI that's light on its digital feet, providing accurate, nuanced, and quick responses, fundamentally enhancing the AI experience.
The impact on the user's experience you described really underscores the evolution of AI interaction to something much closer to consulting a knowledgeable human. Now, can we talk about some practical, real-world examples where the integration of RAG with vector databases is particularly beneficial? Paint us a picture of where and how this technology is making a difference.
Certainly. Picture customer service chatbots, once frustratingly limited. Now, with RAG, they're like helpful, well-informed store clerks. Ask them about product details or return policies, and they'll give you the exact info you need, as current as the company's latest updates. It's transforming customer support from a chore into a breeze. In healthcare, RAG-enhanced systems can assist doctors by quickly scanning the latest medical research or clinical guidelines. This means when a doctor's puzzled by an unusual set of symptoms, the AI can suggest potential diagnoses or treatments informed by the latest studies, sort of like a digital medical assistant. For journalists and researchers, this AI setup is like having an ever-updated, deeply informed research assistant. They can ask about emerging trends or historical data, and the system dives into recent publications or archives to fetch precise details, boosting the depth and speed of their work. Technically, RAG is doing the heavy lifting by sifting through vector databases for the most recent and relevant information and presenting it in an easily digestible format, all on the fly. So, in essence, wherever we need on-point, in-depth, and up-to-date information, RAG and vector databases are there, enhancing everything from fixing a kitchen sink with real-time DIY advice to analyzing complex market trends for quick investment decisions. It's like AI has gone from being a jack of all trades to a master of many.
The applications you've described really highlight how this technology is a game changer across various industries, providing precision and speed that were previously unattainable. To start rounding out our discussion, could you demonstrate how this blend of RAG and vector databases performs with a quick demonstration? Here's a hypothetical. If I were to ask about the impact of urban farming on city environments, how might a RAG system deliver an answer? Remember, keep it succinct. We want to capture the essence of this process in action.
Sure, jump into the shoes of a RAG AI for a second. You get the question, what's the impact of urban farming on city environments? Instantly, the retrieval part of your brain dives into the vector database, pinpointing recent articles, research papers, and case studies on urban farming. Then, all that gathered knowledge lights up your generative mind. It starts crafting an answer, maybe something like this. Urban farming can positively impact city environments by enhancing local food security, reducing food miles, and contributing to biodiversity. It also offers educational opportunities and can improve social well-being. However, it requires careful planning to ensure sustainable water and soil management. Now that's a blend of current data from various expert sources, distilled into a concise response. It's fast, informed, and neatly synthesized, reflecting just what a real user would experience with a RAG system at work.
That demonstration neatly captures the efficiency and insight offered by the RAG model. By querying up-to-date sources, it provides a nuanced response that traditional AI couldn't match without the aid of vector databases. It's almost like having a dedicated team of experts in your pocket, ready at a moment's notice to dissect and explain complex issues. Listeners, as we've explored today, RAG and vector databases are revolutionizing our interactions with AI, enhancing the relevance, accuracy, and depth of the information we receive. AI on AI would like to thank the AI model for sharing its virtual brain space with us today. You've given us heaps to think about. And thank you, listeners, for joining us on this investigative journey into the frontiers of AI technology. Until next time, keep pondering the AI possibilities.